Okay, so let's get going. So if you haven't done it yet, don't forget to make your corrections to your exam if you have any to make. Also for your assignments, I've been posting comments back on Blackboard, so take a look at Blackboard to see if you got all the programs correct, or some of you I asked you to resubmit like 1 or 2 questions here and there. Okay, so any questions about course stuff? All right, so what I want to cover today are some more examples of using loops, and in this case, kind of a specific example of using loops to process images. And the first thing we'll cover is just how can you display an image. So we already covered how you can draw images using like draw rectangles and lines and stuff. But what about like loading a picture and then displaying it? So first off, we'll go through like this template of code that can just display a single image. So as a sample, I have this picture from my kids. It's a little old. These guys are a little bigger now. But the idea will be, first we'll just show how you can load this thing up and display it. And then the second thing will be how can you use loops to process the image. So the idea will be that essentially we'll have a loop that goes, how did I normally do these? We'll have a loop that goes across the y coordinate. So here's 0, 0 up here. And in most of my examples, I had a loop where y, so y goes this way. So y ranges from like 0 to 1 to 2 up to whatever the height of this thing is. And then x goes the other way, 0, 1, 2, etc., up to whatever the width is. And I guess technically it's really not quite the width, it's the width minus 1 and the height minus 1, because we include the 0th value. So if this thing is 10 pixels wide, then it really goes from 0 to 9, or in this case it's way more than 10, it's like whatever, 400 or something like that. Okay, so the idea will be have a loop where y goes from 0 up to the height minus 1, and then for every value of y, that'll be like the row, have another loop inside there that goes from 0 to the width minus 1, and then so when y is 0, x will be 0, then 1, then 2, then 3, and we can do something with like this first line of pixels, and then y gets advanced to 1, and then x loops from 0, 1, 2, etc. We do something with the next line of pixels, and so forth, and so we'll cruise our way through until somehow we do something with every single pixel in the picture. And since computers are pretty fast, the stuff we'll be doing will happen pretty much instantaneously, even if you have a pretty large picture. So that's the general idea. So the first part is how do you display the picture in the first place? So to do that, we have like a fair bit of template stuff, and for now, we won't quite explain how everything in there works, but kind of by the end of the class, you should have a better idea about what's happening in there. So you can pick any picture you want, but if you want to use this picture, I've got it on the calendar page. Okay, so I've got this file called show. So I put the picture right here. If you're doing this using like Dr. Java, then put the picture in the same folder as your Java file. Then you can open it up just giving it the file name. If you're using something like NetBeans, then the picture goes somewhere else. Let's see here. I mean, you can put it anywhere you want, but if you put it like, if your project is called Graphics Lab, then the image would go into that folder. So don't put it into the source folder or anything. The default place where it looks for a file is whatever your NetBeans project is, like in the main folder. So that's the place where you would stick like any default files. If you pick a different place, then we'll see when you want to open it up, you have to give the path name to the whole thing. So like you'd have to say in this case, if I wanted to open ball.png, then I'd have to give it like, C:/users/Kenrick/ whatever, this whole thing /ball.png. So you can go both ways. You can give it that exact path name, or we'll see you can just open it up by just giving it ball.png, and it'll find it if it's in this folder. The advantage of not giving the whole path name is then it'll only work like on the one computer where that path exists. So like if I was trying to run it on my computer or something, it wouldn't work because I probably don't have a folder called whatever your username is / stuff. But I could run it if you gave it to me and it was just use the default folder. So I don't really care because I could change your code or whatever if I need to, but just so you know, it's using the default folder is usually the more convenient way to go. Okay, so mine is back here. Okay, so I put that picture over here in the same folder, this one right here, in the same folder as my showimage.java file. So let's go to that file. So right now I've got nothing in it. It's totally blank, but this is showimage.java. So just to load up a picture, we have a fair bit of things we have to import. So we import javax.swing.jframe. We import java.awt.graphics. Actually, I don't know if I need some of these. Okay, so here's a boatload of imports at the top. javax.swing.jframe. So jframe is the class that lets us pop up a window. Graphics is so we have access to graphics stuff. Color has like common colors, so we can make colors. So we'll use that one. This thing, buffered image. What we'll do is we'll take the image that's on the disk and then load it up into memory. And this buffered image thing is like a version of the disk image, but just stored locally in memory, so it will run faster. You don't have to reload it from disk all the time. This thing file is used so we can read a file from the disk. And then this last thing, image IO, is a thing where it knows how to read in different image formats from the disk. So there's a whole bunch of imports to put at the top. Then we have our public class. Oh, you have a question?
I'm just curious. I noticed on some of the imports, you put java.whatever.star.
Yeah, you could do that too. So what you could do is you could say import java.awt.star, and then that would, the star is like the wildcard, that would include color and graphics. And so if I wanted to, I could take these two out and then use this one in place of it. So you could do that. The Java purists would say this way is better because it specifically says which ones you're using. But
why can't you do java.star and just use all of them? Because I tried it.
Yeah, it doesn't do that. It only does it for the one dot. Like it only does it for the one area between the dots. So like if you do a dot star, it doesn't include everything after it. It only would include like something that was in Java, and that's it.
Would you say it's good, like technique to just import everything, code, and then take out the stuff you don't use, or would you say?
The recommended technique is you would only put the ones in that you think you're going to use, and then as you need more, then you add them in. So that's what most people would say, but I'll admit sometimes I get a little easier and I'll just say import java.awt.star and then don't worry about it. If you do that, it doesn't really make it any worse. Like if you import all of them, when you go and compile it, it only uses the ones that you actually reference. So if you do that, but you actually use them, it's not like it's inserting a bunch of unused stuff.
Okay.
Okay, then we have the same public class thing, and so my thing is called showImage.java, so I'd also have to call it showImage, but you could call it whatever else you want. No, so just like any other Java class. And then we do have this thing extends JFrame, which we'll say more about later, but basically that makes it so it can display a window. So normally we've been doing like public static void main, but before that, I'm going to have this new thing. I'm going to use private and static buffered image, and image equals null. So the idea is, we'll say more about these later, but basically private means you can only access this from inside the show image class. Static means there's one copy of it. Buffered image is the type. In this case, it's going to store the image in memory or in a buffer. And then here I'm calling the variable image. So you could have picked a different name instead of image, but that's just what I picked. And then null is a placeholder that just says I haven't set it to anything yet. So it kind of means like nothing. So right now I've got a image variable, but I haven't set it to anything, or it's set to null. So this null thing is kind of useful, so you can test to see if it's been loaded or not. So if it hasn't been loaded yet, it would be null. But if it has been loaded, it would be not null. By putting this variable right here in like outside of a main, I can access this variable anywhere inside the show image class. So we're going to start adding other methods here in a second. Okay, so this is going to be a place where we hold an image in memory. So the next thing I'll do is add a paint. So just like you did a paint method when you drew the rectangles and stuff, this is the same idea here. Public void paint, and then it takes a graphics G. And the same idea applies. Whenever the window needs to be redrawn, whatever you write inside paint will be called. And so in our case, what we'd like to do would be to display whatever is inside this image on the screen. So we start by doing super.paint. That does some bookkeeping stuff for us with a G inside. And then let's draw the image we loaded. We didn't load it yet, but when this runs, it'll be loaded on the screen. And we can use that by using g.drawImage. And then in parentheses, give it the image we want to draw. In this case, this image corresponds with this buffered image thing up here. And then we give it the upper left-hand corner where we want the image to go. So, like if this is my JFrame screen here, 0, 0 would go at the very top. If I want it to go a little bit over, if I do 0, 0, that includes the title bar, and at least the way we're doing this right now. And so if I want to avoid the title bar, then I'd go over a little bit and down a little bit. So maybe if I pick, like in my notes, I pick 535. So it's like 5 pixels over and 35 pixels down. And so this would be the upper left-hand corner. So then whatever the image is, it would be drawn with that as the upper left-hand corner. By the way, if you don't like this thing with the title bar where we can draw over the title bar, or in this case, I draw under the title bar, the way you would get around it is you would stick a container or a panel inside the JFrame, and then you would draw inside that panel. Then 0, 0 would be the upper left corner of where this panel is. So that's for future reference if you ever decide to do more of this Java stuff. Okay, so I said x coordinate 5, y coordinate 35, and then you can use null as the next parameter, so you don't have to worry about this thing. So that's all we're going to do inside the paint. So every time it's going to redraw the screen, it's going to basically just draw the picture at x coordinate 5, y coordinate 35. Okay, so then the next thing we need to do is we need to add a constructor. So we use public and then the name of the class, show image, and then just parentheses. So we also had to do this when we did the J-frame to draw rectangles and stuff. So it's the same basic thing here. We need to create the window and then make it visible. So, and then set the size. So I'm going to set the size of the window to 810 across, 645 down. I'll set the default close operation to be exit on close. So this is so we can click the X and close the window. Set visible is true. So this sequence of 3 things will set the window size, make it so you can close the window, and then make it so you can see it. So then the next part is to do the main, public static void main string, brackets args. We start out pretty much the same way we also did it when we drew rectangles and stuff. You make a new window, and in this case my class is called show image, so I say show image. I'll call it window equals new show image parentheses. If I stopped here, then it would display nothing. It would make a window but not display anything because I haven't loaded the picture in yet. Actually, so let me go ahead and save it just to see that. If I compile it, set default, oops, I didn't spell it right. Need an L. And so here it creates a window, but there's nothing in it. And I can close it though. So what we've done so far is when this program runs, it creates a window object. And when it creates the window object, it calls this code in here and sets the size so we can close it, makes it visible. So at that point, you see the window pop up. And then when the window pops up, it says, oh, I need to draw whatever's in it. And so it calls this paint method. And then it calls draw image, but I haven't loaded any image yet. And so the image is just null. And so this line right here actually doesn't do anything yet, since there's no picture to draw. So what we should do next is to load up the picture so that there's something inside this image variable to display. So we can do that right here inside main. To load it from disk, I'll make a file variable. I'll just call it input equals new file. And then here inside double quotes, we can give it the path name. In this case, mykids.jpg. And if I just put the file name like this, it's going to look for that file in the same directory as the Java program. Or if you're using NetBeans, it'll look for it in the NetBeans project folder. And once again, if you put it somewhere else, you would have to give the whole path name for it, like c:/ whatever. So you have to give this path name. There's an extra consideration here because the / character is that escape character. So if you remember, if you want to do like a double quote, you have to use / double quote. So if you have just a / by itself, it's going to try to interpret like this M that comes right after it as some special character. And so if you actually want the / character in your string, you have to give 2 backslashes. So / corresponds to 1 / in the final string. So I'd have to put like 2 backslashes everywhere I want a /. So you have to do that if you give the whole path name. In this case, I've got it in the same folder, so I can just give it just the file name. So that should load that file up into input. and then I can finally read it by saying image equals capital image IO dot read and input. So this part reads in whatever that file is into this image, and at that point it should be ready to display. Okay, so if I run this, it's not going to quite work, but here we can see what happens. So if I compile, let's see, whoops, I forgot one thing. So we're going to talk about this thing called exceptions probably next week. And with exceptions, that's when basically Java is worried that something bad could happen when I try to read this file. So maybe the file doesn't exist, or maybe you don't have permissions to read it, or something like that could happen. And so in this case, Java forces us to acknowledge the bad things that could occur. And we have a couple of ways to handle that. One is to use this thing called a try catch. Another thing we can do, just to be quick about it for now, is we add throws exception here on the end. And that'll handle the case where something bad happens. So in this case, if something bad happens, then the program's just going to crash. So later on, we'll see a better way to do this that doesn't have the throws exception on the end. So now let's compile it. So it's not quite done, but if we run it, then here we see we get a blank window, so it doesn't quite work, even though I had all that load stuff. But here, if I do this, if I minimize it and then bring it back, then the picture shows up. And so why is that? The reason is when we run this line right here, so just when we run this first line, it goes and runs this stuff and makes the window visible and then immediately paints it. And at that point, it actually hasn't loaded the image yet. And so it's painting it, but it's drawing the empty image because I didn't load it yet, because it hasn't actually gotten to this line down here. It's doing these in this order, where it gets this line first, it does all three of these things, you see the window, and then immediately it tries to paint it, but we haven't loaded anything yet. So it just draws like the nothing image. And at that point, you see the window with nothing in it, and then after that's done, then it continues on over here and actually loads the image, but you don't see anything because it had already drawn it previously. However, when I minimized it and then maximized it again, when I unminimized it, then it recalls paint, and then at that point I had loaded the image, and so you saw it. So that's the reason why it can be a little tricky doing some of these things, because these things happen kind of at different points in time. But what I could do is right after I finished loading the image right here, I could force the window to redraw itself. And to do that, I give the window name, which is just window, and then .repaint in parentheses. So this forces paint to be called again. So this will redraw the window after it's been loaded in. So I should see the picture pop up immediately this time without having to minimize it and unminimize. So here I run it, this time I see the picture pop up right away. Okay, so there's lots of stuff in this kind of first part. For the most part, as long as you get the template down and understand the basic sequence of what's happening, then it should be fine. So there are some extra details in here you don't really have to know it at this point. One thing I did want to point out is maybe we'll do this later, but we can use draw image to also draw sprites. So a sprite is it's like a little image of a game element. What does it stand for? It stands for something. I forget what sprite stands for. Anyway, so anyways, imagine you've got some game and you have like a character you're moving around on the screen or something. Then essentially we could have an image for the character and then draw the character at different places on the screen. And so you could do that by having different things here in draw image. So just as a small example, let's do this. So I'm kind of getting ahead of myself, but just to give you the idea, I'm going to erase this a little bit later. Oops. So here in this little modification I made, x starts at 10, so this will draw this at x coordinate 10 the first time, and then add 20 to it. So then the next time it paints it, though, it'll draw it at 30 and then 50. So every time it repaints, x will be 20 more, and so you should see the picture kind of move across to the right every time it does a repaint. So for example, I could do something down here. Oops, now I need to import the scanner. All right, so here I just have it, so I input like 4 things, and it does a repaint every time. So every time it does the repaint, if I go back up here, it should draw it where x is 20 over. So there's the first one, and then I go, let's see, I need to make this smaller. So I'm down here, where am I? So I go and I do something, so then it should move it over every time. So you can see it gets moved over every time I hit a key. So if this was smaller, not like a picture of all these kids, but like, you know, you're a game character or something, and I had this map to like the WASD keys or something, then you can imagine it moves stuff around on the screen, depending upon what you input. Okay, so that's getting a little off topic though, but I just wanted to show that this draw image is also what we can use to animate like game elements or whatever things you might want to animate on the screen. Okay, so let me get rid of these. I'll make this go back to 5. And I'll take this out. Okay, so I'm back to the version where it just displayed the image on the screen. The next thing we can show is we can access the colors in individual pixels on the image. And to do that, there's a, if I go back to here, there's a function. I have this thing loaded in image. If I say image.get RGB x comma y and have like an integer, this will go to coordinate xy in the image. So 0, 0 is right here. So if I give this thing like whatever 50 comma 0, it would go 50 pixels over, 0 down, whatever pixel is right there, its value would be copied into the pixel variable. And then to actually get the red, green, and blue out of that pixel, I have to do a little extra maneuvering. I make a color variable. So I say color C equals new color, and then give it pixel. And then I can access c.getRed and c.getBlue and c.getGreen. And then this would give me the red, green, and blue values For the pixel, that's at coordinate 50, 0. So there's sort of like this two-step process to get the red, green, and blue. Is first call this get RGB into a pixel, turn that into a color, then you can get the pixel values. So just as an example, here I have a loop that goes across this. Whoops, didn't mean to do that. Come on, go. We'll have a loop that goes across this top row, and then I'll just print out the red, green, and blue values for every pixel on that row, just so we can see what's happening. So let's see here. So go back in here. I guess I can just stick it right here after the repaint. Or let's put it right here after image. So I'll stick it right here after I've loaded in the image. I'll have a loop, say int x for int pixel for x equals 0. So we'll use the for loop since it's a count-based thing. I want to go all the way across the width of the image, so I can say, well, x is less than image dot get width. So get width tells me how many pixels wide the image is, and then x plus plus. So right here is a loop that goes all the way across one row of the image. And then I'll say pixel equals image dot get RGB x comma 0. So let's get the pixel at x coordinate x, y coordinate 0. And then I'll get a color object C and set it equal to new color pixel. And then finally I can get the red, green, and blue. So how about I'll make a int r comma g comma b. R gets set to c dot get red. G is set to c dot get green. Get blue, blue. And then lastly, I'll just print them out. So at coordinate x plus 0, the colors are R so this prints out at whatever the x coordinate is, and then here this 0 is because it's at y coordinate 0. The colors are, and then it just outputs the red, green, and blue for that pixel value. So let's see what happens here. So we run it. Here it's spitting all this stuff out. Remember I had that spit out before it did the repaint, and so that's why you don't see anything pop up here yet. But then once that finishes, the repaint goes and the picture pops up. So here we can see it's going 800 across, or 799 across, and here's the red, green, and blue. And if we pick, where can we pick something? Kind of in the middle here. It's kind of white looking, so you should have values that are pretty close to 255 for the red, green, and blue. So if we go back up a ways, so around here maybe. So here we can see like at x coordinate 447, you see 253, 255, 244. So that's pretty close to white. And then if we look at one more, like here in the upper left-hand corner, it's pretty dark, so that should be pretty kind of close to black. So that should be values that are close to 0. So we go to the very beginning, and there we got, well, 88, 138, and 25. It's not that close to 0, but closer to 0 than it is to 255. Okay, so any question on what we just did so far? So all we did so far was just print out the red, green, and blue for the top row. Yeah.
So if you basically had all the information from the pixels and you didn't have the image, you could textually regenerate it by setting all the pixels across?
That's right. Yeah, you could. Sure. Yeah. Okay. The other thing we can do, instead of just reading the red, green, and blue, we can also set the color. And so let's do that next. So instead of printing this thing out, I'll take that out. and I'll just set the color to red. So I can make a variable int red color equals new color This is a little weird, messy looking. So here I can get the color red as an integer, and to do that I make a new color object using the red, green, and blue values I want. So in this case all red. This part right here makes a color object, but I really want it in terms of an integer, so then I have to do this .get RGB at the end. And anyway, so that makes this color, whatever I have for these numbers, stored into this variable. Once I have that, then I can set it back on the image by saying image.setRGB, and then give it the coordinates. So I'm going to give it x, 0, red color. So this is inside the loop. So for every x coordinate with the y coordinate of 0, it's going to set it to red. So that top row should now be changed to red after I run this. So I run it, and if you look closely, then you'll see there's a line across the top that's now red. So that's how we just set that top row. So like you were saying, if you knew all the colors, you could have a blank picture and you could set them to whatever you want it to look like. Okay, so rather than just change our thing to red, on the first line, we could have a pair of nested loops so that we could go through every single row on the picture instead of just the top row. So to do that, I'll make another variable up here, y. And then you could either put it, so depending on which way you want to go, usually it doesn't matter. But in my case, what I'll do is I'll make it so we go to y equals 0 and then do all the x's, and then go to y equals 1 and then do all the x's and so forth. So we'll go across like this. If you wanted to, you could go down just as easily. You could say, well, when x equals 0, do all the y values. When x equals 1, do all the y values, and so forth. So we could go down this way as well. So we'll do it the other way, though, where you start with y's. So if we wanted to handle all the y's, then we make a loop outside here for y equals 0. Y is less than image.getHeight and y++. And then inside that loop, I'll put everything that we had before. And let's see here. So here I just added a loop outside. So for every y, we'll have a loop inside that goes through every x value. And then instead of getting the pixel at x, 0, we get the pixel at x, y. And then here it gets the color value. And then in this case, it's not doing anything with it. And then here, this is where we set it to red. Here, if I just change this from x, 0 to x, y, then this should set every single pixel to red. So when I run this, you should just see like a red screen. So here it filled in our whole thing with red. Okay, so any questions about what we're doing so far? Okay, so it's not very interesting to make the whole thing red, and so instead of doing that, let's show how we can take the red, green, and blue for the original image and then do something more interesting with it. And so a common operation would be changing the brightness. So if you wanted the picture to be darker, then we could lower the red, green, and blue for every pixel. So as we get closer to 0, it gets black. As they go up to 255, then they become white. So here we just got the red, green, and blue. And so instead of setting it to red, what I could do is I could maybe decrease each red, green, and blue value by half or more. So I could say red equals red divided by, say, 2.5 maybe. And if I did this, let's see, if I use 2.5, r as an integer, so I have to do a typecast back to an int. So this says, do the division as a floating point number and then turn it into an integer at the end. So I could do that for each one of these. So this makes the red, green, and blue that we originally had for each pixel a little bit smaller. In fact, quite a bit smaller, 2.5 times smaller, which should make it closer to 0. And then instead of setting the color to red, I'll just say int new color. And instead of 25500, I'll use the new red, green, and blue value and then set it back. So this loops through every pixel, gets the red, green, and blue, decreases it, gets the color of the decreased red, green, and blue, and then draws it back on the screen. So we should see a picture that's quite a bit darker. So there we see it's a fair bit darker, so we can make the brightness go down by decreasing the red, green, and blue. We could do the opposite. If you want to make it brighter, then we could increase the red, green, and blue. So instead of dividing, you would just say multiply. And if I run this, then it actually crashes down here. And if we look at the error message, oops, I guess I can't look at it. It went away already. If you look at the error message, it tells us color parameter outside of expected range, green. So anyone have an idea what happened there?
It's bigger than 255.
Yeah, exactly. So I multiplied by 2.5. It was something else, whatever, 150 or something. And so now I got a number that's too big and it doesn't like it. So here's where I could use an if statement. So if I ever got something more than 255, I could just clip it at 255. And that'll make it so it'll compile. The picture will look a little washed out because if you had, a red and a green, now they're not scaled proportionately. Now they just get max at 255. But at least it won't crash. So I could say if R is greater than 255, then I'll make R equal to 255. Do the same thing for the others. So now I shouldn't have anything out of range. When I was making it lower, I didn't have to worry about it because you never go below 0. But when you go higher, then it could go above 255. So now I run it, and here it's definitely brighter, but it is kind of washed out around the faces because I tried to make it too bright, brighter than the color range supports. If I did like a little bit smaller, if I just did 2 maybe. There it's not quite as washed out, but it is a little bit brighter. So we'll do this in a minute here, but this might give you ideas that you don't have to use the same number for the red, green, and blue. So if for some reason you want it to be really red, but not very green or blue, I could decrease the, well, I guess this does nothing to them here, but so this would make it all much more reddish if that's what you wanted. You want to simulate a sunset or something maybe, I don't know. Or, yeah, it's not really a sunset, sunburn, I don't know. We could also change them to grayscale really easily. And so a grayscale image would be where the red, green, and blue are all the same, but they range from 0 to 255. And so if they're all zeros, then you get black. If they're all 255s, you get white. If they're all 127s, you get kind of a gray. And so we could average together the red, green, and blue, and then that becomes like the new number we use for each. So if you want to do like a grayscale here, you could say like int av equals, here, let me comment this out. So we get the original red, green, and blue, and then we could compute the average. So red, green, and blue divided by 3. And then when I get this new color here, instead of using red, green, and blue, I could use AV as the red, the green, and the blue. And so if you had something that was pretty bright, then you get a big number, otherwise it becomes a smaller number. So here's our grayscale picture. And then there are supposedly there are better ways to generate this than just computing the average, because apparently like people don't see the blue part as bright as the red and green. So so this disproportionately increases the blue's value in the grayscale when people really see it a little differently. But anyways, it's probably close enough. If you aren't really into it, it doesn't really matter. Let's see, so that was grayscale. So we can also do more selective color changes. So for example, let's say that this guy over here on the bottom right doesn't like red anymore. He really likes green, which is true. He does like green. And for some reason, he would like his shirt to be green instead of red. And what we could do is go through this picture and then go through every single pixel. And if we find a pixel that's pretty red, then let's change it to green instead. And so, well, one way we could think about this would be if we do something like this, is you use like a paint program. And let's see, I think there's an eyedropper in here somewhere. Where the heck is it? Here we go. So if you use a paint program of some kind and you go and look at these pixels, then here you can see the red's pretty big, like 203, and the green and blue are much smaller. So if you look at these pixels, in this case, go to the tree over here, the green and the red are pretty big, but the blue is small. And so what we might decide to do is something like, well, it looks like all these pixels over here, the red is about 2 times bigger than the green and the blue. Maybe not for all of them, but it looks like that's the case most of the time. So if we go through this image and find any pixel where the red is more than twice the green and it's twice the blue, then let's change those from red pixels to green pixels. And so one way we could change it but still maintain like some of these color differences is we could do something like if you have an original red equals whatever 180, green equals something 50. So you have something like this. Then what we could do to make it more green is we could say swap the red and the green. So this color could become red equals 50, green is now 180, the blue could stay the same at 67. So this would make it so it's really, really red to be really green instead, but still have the same blue component, so it doesn't become just pure red or whatever. It still maintains some of the original texture. So let's try that. So if we go back to our program, so we had a loop through, we get the red, green, and blue. We can do an if statement. If the red is greater than twice the green, and the red is greater than twice the blue, then in this case, let's swap the pixels around. So I'll make it so the red equals the green, the oops, I need a temp here. So I can't quite do this. This is what I want to do. I want the red to be the green and the green to be the red. If I did them in this order, then I have a problem because the red gets the green value, and then the green gets the red value, which is now the green value. So it would get the same value that it had before. So I need to have like a temporary variable, int temp red equals r. So here I remember the red, red becomes the green, green becomes whatever red I originally remembered. So here I just swap the red and the green value, and then otherwise it doesn't do anything. The red, green, and blue stay the same as whatever they were. And then in that case, I guess here I can just go ahead and delete this. I can delete this too. And I can actually take all this and move it in here. So if this is the case where we have one of these really red pixels, then we swap the colors. We get a new color that is whatever the red, green, and blue. Actually, there's another way I could have done this. I could have just swapped them in here and then set it back. So, so only for the really red pixels does it get the new color and then set it back. So what I was saying is I could have just skipped these actually. This would probably have been a little better. I could have skipped those and just swap them like this. And so in this new color, the green, what was the old green becomes the red, and then what was the red becomes the green, and then the blue stays the blue. So this would be the shorter way to do it, but if you like this idea better, maybe that works too. Okay, so if we try this one, then here we see the shirt is turned green, and so it worked pretty well. The only part that didn't quite work is if you look really closely, there's like a little bit of lip here that became green, and there was some reddishness like in the ear that became green. And I think that's about it. Oh, I think this didn't used to be green either. I think that was red. So, is that right? I think that was red. No, it was green. Okay. So it worked pretty good, but not perfectly. So maybe you don't want these little bits of the ear to become green. So you have a couple of choices. One thing you could do is you could go back to the paint program and then try to say, well, right here in the ear, it was like a red of 182, green of 85, and a blue of 77. So maybe somehow you could change that formula of the red's twice the green and the blue so that it doesn't capture these. And that'd be one way. But probably the easier way is, instead of looping over the entire image, looking at every single pixel, we could instead only loop around the shirt area over here. And so if we go back over, it's got the coordinates down here in the bottom. So if I go to like just this coordinate system, like right around, if I try to get a box like right around here, for example, then I could miss the top of the ear and get just pretty much the stuff around the shirt. So we look around, this has like an X coordinate of about 500. What did I use in my notes? This has an X coordinate of around 500. In my notes I put 512. And then the Y coordinates around 386. So we could start there, and then we could just go all the way out to the ends of the image and just process that rectangle. So let's do that. And so instead of X starting at 0, we start at about 500 or 512, and Y starts at 385. And then in this case, I'll still go all the way up to the height and the width, but I could have shrink those down if I wanted to as well to get a smaller rectangle. So in this version, so the ear here is unscathed because we didn't loop over those pixels. We just went over here. And so it actually looks, if you didn't know better, you might actually think that was the actual color of the shirt, but instead we manipulated it using our primitive version of Photoshop programming. I guess it's not quite perfect. There's some little edges around here that are still reddish, but anyway, so we could play around with the formula, I guess, some more and capture those if you wanted to. Okay, so that's the basic idea. And so what I have you doing on the second assignment is using this basic thing to do like red eye reduction. And so they're like the red eyes and have loops that go around the eyes and just find the red and turn it into something that's not red. Okay, so for the drill today, it's a pretty similar thing. You'd have these loops that process an image. And in this case, on the assignment, I gave you there's like a secret picture inside the image. And if you follow the instructions, then you can manipulate the colors so the image will come through. So basically, you can see the image on the red, but not on the green and the blue. Okay, so any questions about what we've done? All right, then I'll stop talking.